All right, so we're going to look at how to simplify a radical. We want to start here by taking a look at square root of 96. Our first step here is we want to find the prime factorization of 96. So let's do that over here. We're going to have 96, and there's a video earlier in the week where we go over this, but if it's an even number, we know we can divide it by 2. So 96 is 2 and 48. 48 is 2 and 24. 24 is 2 and 12. 12 is going to be 2 and 6, right? And then 6 is going to be 2 and 3. Now take a look at this. How many 2's do we have? We have 1, 2, 3, 4, 5. We have 5 2's and 1 3. So when we go to write this prime factorization, we are going to have 2 to the 5th times 3. Now what we want here is, this is a square root, so there's kind of an imaginary 2 up here in the index. We want to be able to divide the index by the exponent. We can see right now that 5 is not divisible by 2, but what we're going to do is we're going to break that up. We can't write 2 to the 5th is not divisible by 2, 5 is not divisible by 2, but we can break that up using the exponent rules, and we can write that as 2 to the 4th times 2, and then I've also got this 3, right? So as you can see, what we have here is this piece is going to be able to come out, but this is what's going to be called our leftovers. These are going to be leftovers, and those are going to stay underneath the radical. So now we're going to use this trick of dividing the exponent by index. So we're going to bring out a 2 to the 4th, and when we bring that out, we divide that exponent by 2. We still have our square root, and then we've got those leftovers left under there. Now, take a look. We can evaluate this. 4 divided by 2, so we're going to have a 2 squared on the outside. Underneath, 2 times 3, we can multiply those, and we're going to have a 6. Finally, we can evaluate 2 squared, and we're going to get 4 radical 6. So you can see we have simplified what's underneath the radical. We started with square root of 96. After we broke it up, we got this written as 4 radical 6. Now let's go over here and take a look at a cube root. The process is going to be very similar, except for when we bring stuff out, we're going to divide the exponent by 3. So let's do the prime factorization of 324. Again, 324 is an even number, so I know I can divide that by 2. I get 2 and 162. 162 is an even number, so I can divide that by 2. And I'm going to get 2 and 81. 81 is not an even number, but I think I can divide that by 3. That's going to give me 3 and 27, which is then going to give me 3 and 9, which finally is going to give me 3 and 3. So my prime factorization, I'm going to have my big cubed root, and now take a look. You see I have 2 2's, so I'm going to have a 2 squared. A 2 squared. And then take a look over here. You see how many 3's do I have? 1, 2, 3, 4. I'm going to have 4 3's. So that's going to be 3 to the 4th, because you can see there are 1, 2, 3, 4 of them. Now, in this case, since this is a cubed root, we are looking for exponents that are divisible by 3. Well, 2 is not going to be divisible by 3, so that's going to stay underneath the radical. 3 to the 4th. 4 is not divisible by 3, but we're going to go ahead and break up 3 to the 4th into, so this is where we break this up. Since we can make this 3 to the 3rd times 3 to the 1st, and then we still got that 2 squared left over. So you can see we took this 3 to the 4th and we broke it up to 3 to the 3rd and 3 to the 1st. Why did I do that? Because now that exponent is divisible by 3, so we bring out a 3. When we bring it out, we divide the exponent by this index right here. So we divide this exponent by this index right here. We still have a cubed root here. This came out, right? That's how we got this right here. And then this is going to be our leftover stuff. So we're going to have a 3 to the 1st times 2 squared left over. Now we're going to evaluate this right here. This right here, 3 divided by 3, is just going to give us 3 to the first, and then we have a cubed root of, and now let's combine this stuff left over. 3 times 2 squared is going to be 12. So that's our final answer here. We simplified the radical cubed root of 324. We can now write that as 3 times the cubed root of 12.